Hello students, today we are going to discuss about next chapter, thermal properties of matter. So what do you mean by thermal properties of matter? So the properties of the matter which are related to the conduction of heat, they are called as thermal properties of matter. First of all, what do you mean by matter? Matter is nothing but a substance which occupies space as well as having fixed mass. So first definition, temperature. How do you define temperature? Temperature, you already studied about some basic concepts related to the temperature and heat energy in your previous high school classes. So first, what do you mean by temperature? It is the degree of hotness as well as coldness of a body. It is a measure of or degree of hotness or coldness of a body. When heat energy is supplied to a particular body, if the state of the system does not get changed, then the temperature increases. So if the state of the system, for example, if you supply certain quantity of heat to a particular solid, if its state remains solid only, then its temperature increases. So otherwise, when heat energy is removed by a particular substance, then its temperature decreases. Therefore, temperature is the measure of, or it is a degree of hotness or coldness of a body. So that is the definition of what? Temperature. Next, unit. SI unit of temperature is Kelvin, symbol is K, and the dimension is theta. Next, thermal equilibrium. So whenever there is a temperature difference between the two bodies, then there will be flow of heat. So when do we say the two bodies are said to be in thermal equilibrium? Thermal equilibrium means, so if the two bodies which are placed in contact with each other, if they are having the same temperature, then they are said to be in thermal equilibrium. If and only if there exists a temperature difference between the two objects, then there is a flow of heat. If there is no temperature difference between the two objects, then the two bodies are said to be in thermal equilibrium and there will be no flow of heat between those two objects. So in order to measure the temperature, normally we will use different types of scales. Most commonly used three scales are Celsius scale, Fahrenheit scale as well as Kelvin scale. In order to construct a scale of temperature, normally we will use two fixed points. One is lower fixed point, which is usually ice point that is 0 degrees Celsius, and another one is upper fixed point. Upper fixed point is steam point, that is 100 degrees Celsius. So any scale, all scales are having two fixed points. One is lower fixed point and the other one is upper fixed point. So as I said earlier, there are three scales here. First one is Celsius, Fahrenheit as well as Kelvin. In Celsius scale, 0 degrees Celsius, ice point is considered as lower fixed point and steam point, that is 100 degrees Celsius, is considered as upper fixed point. In between lower fixed point and this upper fixed point, there are how many divisions? 100 divisions are there. In this case, there are 100 divisions. Each division corresponds to 1 degree Celsius. Next, in case of Fahrenheit scale, lower fixed point is 32 degree Fahrenheit and the upper fixed point is 212 degree Fahrenheit. In this case, there are 180 divisions. There are 180 divisions in this scale. And the third type of scale is Kelvin scale. Here the lower fixed point is 273.15 and the upper fixed point is 373.15. In between these two fixed points, there are 100 divisions. So next, there is a formula to convert the temperature from one scale to the another scale. So the table runs as follows. So reading on any scale, minus lower fixed point divided by upper fixed point minus lower fixed point is always equal to constant. So I will write the constant as x. So now here, in case of Celsius scale, so reading on any scale, in Celsius scale, degree Celsius minus lower fixed point is 0 degree Celsius divided by upper fixed point is 100 degree Celsius minus lower fixed point is 0 degree Celsius. That is equal to, in case of Fahrenheit scale, so reading on any scale, in case of Fahrenheit scale, I will take degree Fahrenheit, F minus lower fixed point is 32 divided by upper fixed point is 212 minus lower fixed point 30. That is equal to Kelvin scale, K minus 273.15 divided by 373.15 minus 273.15 0.5. That can be written as follows: C by 100 is equal to F minus 32 divided by 180, that is equal to K minus 273 divided by 100. For calculation purpose, I will take 273.15 as 273 as well as 373.15 as 373 only. So here, by using this formula, you can convert the temperature from one scale to the other scale, that is from Celsius scale to the Fahrenheit scale. That is C by 100 is equal to F minus 32 divided by 180. If you know the temperature in degrees Celsius, you can convert it into Fahrenheit. At the same time, if you know the temperature in degree Fahrenheit, then you can convert it into Celsius by using this formula. C is equal to 5 by 9 into F minus 32. If you know the temperature in degree Fahrenheit, you can convert it in which scale? Celsius scale. So now there is a problem. So at what particular value both Celsius scale as well as what Fahrenheit scale shows the same reading. So I will take that value as x, unknown value as x. So instead of writing C here in the LHS, I will write x, that is equal to 5 by 9 into, again instead of F, I will write it as x minus 32, cross multiply, simplify, then you will get x value as is equal to how much? Minus 40. At minus 40, both Celsius scale as well as what Fahrenheit scale shows the same reading. Okay students, next, the device which is used to measure the temperature of a given substance or a given body is called as thermometer. So by using thermometer, you can measure the temperature. So there are different types of thermometers are there depending upon different types of applications. Usually we will consider different types of thermometers. So the most commonly used thermometer in our day-to-day life is liquid in glass thermometer. So that is also called as what? Mercury in glass thermometers. So here mercury is used as liquid in this case. So here the range of this temperature in this type of thermometer is minus 50 degrees Celsius to 350 degrees Celsius. Next, gas thermometers. Instead of mercury, you can use gas also. So since gas undergoes expansion, that means there will be a change in what? Pressure as well as volume with respect to the increase in temperature, and hence the gas can also be used in case of what? Thermometers. So in case of gas thermometers, there are two types actually: constant pressure thermometer and constant volume gas thermometers. Next, resistance thermometer. So instead of using this liquid or gas, we can use solid material such as a platinum wire whose resistance changes with respect to the change in temperature, and hence platinum wire can also be used to construct thermometer. Those type of thermometers are called as resistance thermometers. In this case, the range is from minus 200 degrees Celsius to 1200 degrees Celsius. Next, thermoelectric thermometers. So usually they are called as what? Thermocouples in order to measure temperature. Two different metals are used to construct a device which is called as a thermocouple. So by using thermocouple also you can measure the temperature of a given substance. Next, pyrometers. So in order to measure the temperature of a star, particular star, so normally we will use pyrometers. Next, vapor pressure thermometers. So in order to measure very low temperatures, normally we will use vapor pressure thermometers. So this is about thermometer and its different types. Next, thermal expansion. So what do you mean by thermal expansion? So the increase in dimension of the object. The increase in dimension of the object without any change in state of the substance with increase in temperature is known as thermal expansion. So what happens when heat energy is supplied? Two things are possible. There may be increase in temperature or there may be change in state of the substance also. If there is no change in the state of the substance, then the temperature, the increase in temperature will lead to the expansion. So that is called as thermal expansion. The change in dimension of the object. The change in dimension of the object, if the state of the system does not get changed with increase in temperature, is called as thermal expansion. So all the three states, solids, liquids as well as what? Gases undergoes expansion with increase in temperature. Expansion is maximum in case of gases and it is very less in case of what? Solids. Since the intermolecular force of attraction is maximum in case of solids while it is least in case of what? Gases, and hence expansion is maximum in case of gases and it is minimum in case of solids. Solids undergoes all the three types of expansion. It can undergo expansion in all the three dimensions, while liquid as well as what? Gases undergoes expansion only in volume. So they can undergo volume expansion only, while solids can undergo expansion in all the three dimensions. So first one, linear expansion. Linear expansion means the increasing length of the object with increasing temperature. So for example, I will take a wire having the length L or L0, initial length is L0. So if the temperature is increased to a very small extent, if delta T represents the small change in temperature, then the length of the wire gets increased to a very small extent, that is delta L. Change in length of the wire is delta L, original length is L0, the change in length is delta L, therefore new length, final length can be written as L is equal to L0 plus delta L. So that is the final. How can you relate the initial length as well as what? The final length as well as the change in temperature. So here it can be written as the change in length delta L is directly proportional to the original length, that is L0, into change in temperature, that is delta. So the change in length is directly proportional to the original length as well as what? Change in temperature, that is delta T. And in terms of constant, we can write delta L is equal to alpha into L0 into delta T, where alpha is a constant which is called as coefficient of linear expansion. Alpha is a constant called as coefficient of linear expansion. The degree or extent to which there will be an increase in length, that will be indicated by alpha, which is called as coefficient of linear expansion. What is the formula for alpha? So now I can write the formula for final length. Final length can be written as L is equal to L0 plus delta L means alpha into L0 into delta T, or it can be written as L is equal to, take L0 common, 1 plus alpha into delta T, or L minus L0 is equal to, L minus L0 is equal to 1 plus alpha into delta T. So this is the other form. So now alpha can be written as alpha is equal to, directly I can write alpha is equal to delta L divided by L0 into delta T. Alpha is equal to delta L divided by L0 into delta T, where delta L represents the change in length, L0 represents original length, delta T represents change in temperature. So what is alpha here? The ratio of change in length, the change in length to the original length with respect to the change in temperature. That is known as coefficient of linear expansion. Its unit per degree Celsius per Kelvin. So alpha indicates up to what extent the length of the object is increased with respect to the increase in temperature. So the increase in length of the object with increase in temperature is called as linear expansion. So then L0 is the original length, L is the final length, delta L is the change in length with respect to the change in temperature, delta T. So the final length can be written as L is equal to L0 into 1 plus L is equal to L0 into 1 plus alpha into delta. So this is about linear expansion. Next, second type of expansion in solids is area expansion. The increase in area with respect to the increase in temperature is called as area expansion. For example, if A0 is the original area and if A is the final area, if delta A represents the change in area with respect to the change in temperature, delta T. So similar to these equations, you can write the change in area delta A is directly proportional to the original area into delta T. Or in terms of constant, you can write delta A is equal to beta into A0 into delta T, where beta is a constant called as coefficient of area expansion. Beta is a constant called as coefficient of area expansion. What is the formula for beta? Here, beta is given by delta A divided by A0 into delta T. The change in the ratio of change in area to the original area per degree Celsius rise in temperature. Its unit is also same, per degree Celsius per Kelvin. What is the formula to write the final area? That is A is equal to A0 into 1 plus beta into delta. So next, volume expansion. Third type of expansion in solids, that is known as volume expansion. So that is nothing but the increase in volume of the object with increase in temperature. So if V naught is the original volume, V is the final volume, delta V represents the change in volume with respect to the change in temperature delta T, then we can write V is equal to change in volume delta V is directly proportional to V naught into delta T, or this can be written as in terms of a constant, right? Delta V is equal to V naught into gamma into delta T, where gamma is a constant called as coefficient of cubical expansion, and that is also called as volume expansion, where gamma is a constant called as coefficient of volume expansion. So similarly you can write gamma is equal to delta V divided by V naught into delta. So this is about alpha, beta as well as gamma. So how they are related? So coefficient of linear expansion, area expansion as well as gamma expansion are related by as follows. That is alpha is to beta is to gamma is equal to 1 is to 2 is to 3. So this is about the expansion in case of solids. So first, thermal expansion means the increase in dimension of the object if there is no change in the state with increase in temperature is called as thermal expansion. So in case of solids, it can undergo expansion in all the 3 dimensions. There may be a change in length, area as well as volume with respect to the increase in temperature. So based on the first type of expansion is linear expansion, the increase in length with increase in temperature. So there is a constant called as coefficient of linear expansion, that is alpha, and the next type of expansion is area expansion. The increase in area with respect to the increase in temperature is called as area expansion. In this case, the constant is called as coefficient of area expansion, that is beta. Next, third type of expansion is volume expansion. The increase in volume of the substance or solid with respect to the increase in temperature, and the constant is called as coefficient of volume expansion, that is gamma. And the ratio alpha is to beta is to gamma is equal to 1 is to 2 is to 3. Okay students, next some of the few important applications of what expansion in case of solids. So first one is effect of temperature on time period of simple pendulum. So you know the formula for time period of simple pendulum, that is T is equal to 2 pi into root of L divided by G. So first, what mean by time period? Time period means the time taken to complete one oscillation. So here the time period of a simple pendulum is directly proportional to the square root of length of the simple pendulum. If the length of the simple pendulum increases, then the time period also increases. So in case of simple pendulum based clocks, what will happen during the summer when the temperature gets increased? When the temperature increases, so as per linear expansion in case of solids, length also increases. Length of the simple pendulum increases. If the length increases, what about the time period? Time period increases. So what about the clock? So time period increases. That means time taken to complete one oscillation increases. Clock becomes slower. Clock becomes slower during summer. Clock becomes slower in summer. That means it loses the time. It will not show correct time when the temperature gets increased. So when the temperature increases, as according to the linear expansion concept, length of the simple pendulum increases, time period also increases. Time period increases means more time taken to complete one oscillation, and hence the clock becomes slower in summer, and hence it loses the time. So in case of winter, what will happen? In case of winter, so temperature decreases, length decreases, time period decreases, and hence the clock becomes faster. So clock becomes faster during winter, and hence it gains the time. So during the summer it loses the time, where in winter it gains the time. So this is because of what? Linear expansion in solids. Usually material expands on heating as well as contracts on cooling. So during the summer, as the temperature is increased, varied from normal room temperature or atmospheric temperature, what will happen? Length increases, time period increases, and hence what happens? The clock becomes slower during the summer. At the same time, during the winter, what will happen? So length of the simple pendulum decreases, time period decreases, and hence the clock becomes faster. So that means the clock will show correct time only at room temperature, at a particular temperature, and when the temperature increased or when the temperature is decreased, it will not show correct time. So how much time will be lost during the summer? That can be calculated by using the formula time lost during the summer. So that is given by delta T is equal to half into alpha into delta theta into T. So where alpha is the coefficient of linear expansion of the metal used. So delta theta, that is the change in temperature, where T is the time. So here amount of time lost in a day, that is given by delta T is equal to half into alpha into delta theta. 1 day means how many seconds? 86,400 seconds. This much amount of time will be lost in a particular day during which season? During summer season. If you know the value of alpha and if you know the value of delta theta, you can calculate the amount of time lost by a clock during the summer. So this is about one of the consequence of what? Expansion in case of solids, that is effect of time period on a clock based on what? Simple pendulum. So formula for time period of the simple pendulum. So remember this thing. So clock becomes slower during the summer as well as it becomes faster during the winter, and hence it loses the time during the summer and hence it should gain the time during the winter based on this expression. And how much time will be lost during the summer in a day? This is the value. And how can you overcome this problem? If you want to overcome this problem, if you want to reduce the time lost by a clock in a day, so alpha value should be more. So that can because of that reason only. So the modern clocks, modern watches are constructed by using a metal that is called as what? Invar. Normally, invar material is used since the value of alpha is very less for invar material matter, and hence invar is most commonly used in modern watches as well as clocks. So next, based on this formula, there is a problem. A pendulum clock loses 12 seconds in a day when the temperature is 40 degrees Celsius, and it gains 4 seconds in a day when the temperature is 20 degrees Celsius. At what particular temperature the clock will show the correct time? So when the temperature is increased to 40 degrees Celsius, it loses 4 seconds. When the temperature is decreased to 20 degrees Celsius, it gains 4 seconds. When the temperature is increased to 40 degrees Celsius, it loses 12 seconds, and it gains 4 seconds when the temperature is decreased to 20 degrees Celsius from the normal room temperature. And also we are asked to calculate the value of what? Alpha. Alpha means coefficient of linear expansion. So we can use this formula, that is delta T is equal to half into alpha into delta theta into 86,400. So first, when the temperature is increased to 40 degrees Celsius, it loses how many seconds? 12 seconds in a day. That is, in a day means how many seconds? 86,400 seconds. That is equal to half into alpha value. We don't know the value of alpha into delta theta. So here temperature is increased to 40 degrees Celsius from a particular value. We don't know that value. I will take that value as theta only. So take this equation as 1. Next, when the temperature is decreased to 20 degrees Celsius, when the temperature is decreased to 20 degrees Celsius, then what will happen? So it gains 4 seconds. That is minus 4 divided by 86,400 is equal to half into alpha into 20 minus 3. So here I will take plus 12 and here I will take minus 4. Reason why means, so if you want to, in order to show the correct time, so it should gain how many seconds? 12 seconds, and hence I will take plus 12 here, and Here when the temperature is decreased to minus 20 degrees Celsius, it gains 4 seconds. So in order to show the correct time, so it should be minus 4. Now divide equation 1 from 2. If you divide the equation 1 from 2, 86,400 gets cancelled, and hence in the LHS you will get minus 4, minus 3, that is equal to 40 minus theta divided by 20 minus theta. So now cross multiply, that is minus 60, that is equal to plus 3 theta plus 3 theta is equal to 40 minus theta. So that is equal to how much? 4 theta is equal to take minus 60 to RHS, it becomes 100. Therefore theta is equal to how much? 25 degrees Celsius. So at a temperature of 25 degrees Celsius, the clock will show the correct. So and you are also calculate the value of alpha. How can you calculate the value of alpha here? Substitute the value of theta as 25 degrees Celsius in any one of the equations, then you get the value of alpha. That is here 12 divided by 86,400 is equal to half into alpha into 40 minus 25. Simplify, then you get the value of alpha as how much? 1.85 into 10 power minus 5 per degree Celsius. This is the value of alpha. Alpha means coefficient of linear function of the metal which is used to construct that particular clock. So next students, next concept, expansion in case of liquids. So similar to the solids, liquids also undergoes expansion. So here in a beaker some amount of water is taken. So here when this vessel is heated, so then what will happen? Liquid undergoes expansion. So in case of expansion, in case of expansion of the liquids, we have to consider the expansion of the vessel also. While studying the expansion of liquids, we should consider the expansion of the vessel in which it is taken. So initially here the liquid is filled up to the level P here. When the vessel gets heated, what happens? First vessel, the temperature of the vessel increases. First vessel undergoes expansion, and thereafter so liquid starts to heat, and then liquid also undergoes expansion. So here in this case PQ represents the expansion in case of water vessel. PQ represents the expansion of vessel. Expansion of vessel. Where QR represents so the apparent increasing volume. Apparent increasing volume of the liquid. While PR represents the volume, actual increasing volume of the liquid. So here PQ represents the expansion of what? Vessel here, where QR represents what? So after some time, the temperature of the liquid also increases, liquid also undergoes expansion, and the liquid the level of the liquid gets increased up to the rim also, and hence normally you will observe only this thing only, QR only. So you may not be able to observe PQ. Reason why means expansion in solids is very less when compared to the what? Liquids, and hence you may not be able to observe the PQ, where QR represents not the actual increase in volume of the liquid, there is an apparent increase in volume of the liquid in the vessel. Where QR represents the apparent increase in volume of the liquid. Therefore, what is the actual increase? Actual increase in volume of the liquid in a vessel is PR. Therefore, PR is the actual increasing volume of the liquid, while PQ is the expansion in vessel, where QR is the apparent increasing volume of the liquid. Then how they are related? Actual increase, apparent increase, and expansion of the vessel. So actual increase in volume of the liquid is equal to apparent increase in volume of the liquid plus expansion of the vessel. That's what I said earlier. So here, while studying the expansion in case of liquids, you should take the expansion of vessel also. So and hence in this case, in case of expansion of liquids, we have three types of coefficients. One is coefficient of real expansion of the liquid, coefficient of apparent expansion of the liquid, as well as coefficient of expansion of the vessel. Therefore, coefficient of real expansion is equal to coefficient of apparent expansion plus coefficient of expansion of the vessel. So what is the formula to calculate the apparent increase or change in level of the liquid with respect to the vessel? So you know the formula for apparent change in volume. So apparent change in volume, that is delta V, is directly proportional to the original volume, that is V into delta T. In terms of constant, you can write delta V is equal to V naught into original volume V into, in terms of constant, you can write gamma into delta T, where gamma is the coefficient of volume expansion. So therefore, based on this, you can write apparent change in volume of the liquid with respect to the vessel can be written as delta V apparent. Apparent increase in volume of the liquid is equal to original volume of the liquid when the temperature is normal into gamma, that is coefficient of apparent expansion, into delta T, where delta T represents the change in temperature. So now, based on this equation, you can write delta V apparent is equal to V into coefficient of apparent expansion can be written as what? Coefficient of real expansion minus coefficient of expansion of the vessel into delta T. Therefore, coefficient of apparent increase in volume is equal to V into coefficient of real expansion of the liquid minus how alpha and gamma are related. So alpha is to beta is to gamma is equal to 1 is to 2 is to 3. That is equal to, instead of writing gamma, you can write alpha also. If the value of alpha for a vessel is given, then you can write, instead of writing gamma, you can write 3 alpha into delta T. This is the formula that can be used to calculate the apparent increase in volume of the liquid. Therefore, while studying the expansion in case of hot liquids, we should consider the expansion of the vessel also. This is about the actual increase in volume of the liquid, apparent increase in volume of the liquid, as well as corresponding 3 types of coefficients, and the formula to calculate the apparent change in volume of the liquid.